Good morning. So welcome back to Unit 4 measurement of physical parameters of the sensors and measurements. So in this lecture series, we will explore how physical phenomena such as temperature, pressure, flow, displacement, vibration, and acceleration are measured using the using sensors and bridge circuit. So these measurements form the backbone of your modern instrumentations and control systems. So this unit so mainly we focus how study study the uh, how study the modern technologies, modern industrials and researchers. So how we are going to sense the and how are going to predict values and give the accurate and perfectly. So for this, you have to develop the sensor technology. So in this, the first one is the temperature and the measurements. So in this, you are going to convert the thermal energy into the resistance or voltage. So in this, the RTDs, the first one is the RTDs. So resistant temperature detectors. In this, so the main working principle that resistance means like metals. So metals is made up of platinum. This you are going to changes with the temperature, right? So these are mainly they are accurate and stable, right? So the next one is the thermocouples. So thermocouples made up of two different metals joined together. They are generated voltage when exposed to the temperature differences. So that is the two joint connecting together. So that between the junction is called the Seebeck effect. So they are rugged and they can measure the high temperatures. Right. So the next one is the pressure and force management. So using the pressure and force, you are going to measure the things. So that is pressure or force. That is example for pressure and force measurement. Strain causes uh, like this. Strain causes, which is they are going to change the resistance value when stretched or compressed used in the force sensor. So when here the load cells, the device that can use the strain causes or piezoelectric materials to measure the weight or force. So here the diaphragms bellows. So in this diaphragms, the mechanical elements that deform under pressure and converting pressure into displacement on the electrical signals. So these are the pressure and the force measurement. So the next one is the flow and the level measurements. So in this flow and the measurements is we are going to use the fluid dynamics and the tank monitoring. So the fluid dynamics in this under the category of flow measurements and the tank monitoring is the under the category of level measurements. So the fluid dynamics that is the venturi tubes we are used here. We are going to measure the pressure drop in the fluid flow. So here the electromagnetic meters, so which is used to measure how the flow of conductive fluids and also here use the ultrasonic meters. We are going to use since the sound waves to measure the flow speed, right? So the next one is the level measurement. So these level measurements are used here in the float sensors. So this float sensor use the mechanical flows that rise or fall into the liquid level. Here, the sensors, the capacitive sensors and ultrasonic sensors used here. So, the capacitive sensor to predict the changes in capacity, which is in the liquid level, and the ultrasonic sensor sends the pulses to measure the distance to the to liquid surface. So, the next one is the displacement and velocity measurement. So the basic things is here displacement and velocity. Here you are going to measure that is LVDTs. The LVDTs is nothing but linear variable differential transformer. So here you are going to measure the linear displacement with the high precision value, right? Next one is the Tagno generator, which is going to produce the voltage proportional to the rotational speed and also used the optical encoders. This optical encoders is the digital devices which is going to measure the position or velocity using the pulses. So the next one is the vibration and acceleration measurements. The basic thing that is the measurable quantity is the input is the vibration and accelerometers. So this accelerometers So which is both are used mainly in the health and motion. So the accelerometers, which is oftenly usually used piezoelectric, they generate the voltage when subjected to the acceleration. The next one is a seismic sensors, so which is used to detect the low frequency vibrations, useful for earthquake monitoring or heavy machinery things, which is used here. Next one is the AC and DC bridges used here. It is used to measure the resistance changes in sensors like RTDs and strain gauges. So both sensors, we are used to the bridges here, DC bridges used here, that is the Wheatstone bridges. And the next one is the Maxwell and Chain, that is AC bridges, which is used to measure the inductance and capacitance value. That is important for displacement and capacitive sensors used here. So compared to the all the sensors technologies, we conclude that this measurement of physical and physical parameters is the foundation of the instrumentation. Okay, so here the sensor is the basic physical phenomena into the, we are going to convert this physical phenomena into the electrical signals while using the bridge circuits, which is helps to measure these signals precisely. So together they enable accurate monitoring and control in engineering systems. And also we are giving the wonderful solution for that. So that's all about the measurement of physical parameters.